coming up on Garden Talk.
Because after the sun comes out and the plant starts photosynthesizing, the stomata close and all that good stuff. So you really want to harness that early on in the day, like as early as possible, before sunrise, as the sun is coming up. That's very important to get the most out of it. Plants require different things at different phases of the plant's life. The big thing is IMO, or indigenous microorganisms. The microbes have such a large factor in soil and how it all works together. You realize that that's really more important than supplementing nutrients. Natural farming inputs within this brew as well, and you're multiplying those microbes from your IMO into the water for 24 to 36 hours usually. Nature knows what it's doing, and then we're trying to observe and mimic that as much as possible.
What's up, everybody? If you that don't know me, my name is Chris, aka Mr. Grow It, and you're tuned into the Garden Talk podcast. This is episode number 59. In this episode, I interview Blue, but some of you know him as BluegrassGreenthumb on Instagram. He has been gardening for 6 years and grows plants such as moringa trees, comfrey, alfalfa, fruits, veggies, and a lot more. He's big into the natural farming approach, and he's also big into plant science. In this episode, he talks about plant science that isn't really taught or even talked about much. Thanks to all of you who support this podcast through Patreon. If you'd like to support, you can do so by going to patreon.com/MrGrowIt. Before we get into it, I want to acknowledge that one of my goals for this podcast is to bring zero cost for information about gardening, all plants, to the general public. That being said, I'd like to thank the sponsors of today's episode who helped make that goal possible. Thanks to AC Infinity for sponsoring this podcast. They sent me over their grow tent, which has a canvas density of 2000D, making them the thickest grow tent on the market today. It has an aluminum plate that mounts your controller to the grow tent with a lightproof pass-through for cable routing. The frame has 50% thicker steel poles and carries 2 times more weight than the standard grow tents. Coupon code MrGrowIt will get you a discount on their products, and I'll leave a link to their website down in the description section below. Thanks to Spider Farmer for being a sponsor. A new grow light they released here in 2022 is the SE1000W. This was designed specifically for those of you who run CO2 in your grow space and really want to maximize the light intensity. It has a 10-bar design for an even light spread, pulls 1000 watts from the wall, and comes in at 2.9 micromoles per joule efficacy. The recommended coverage area is 4 feet by 4 feet or 5 feet by 5 feet. Use discount code MrGrowIt5 to save on all Spider Farmer products, and I'll leave a link in the video description section below. Alright, we are back. Welcome to the Garden Talk podcast. Today I am joined with Blue, but he goes by BluegrassGreenthumb on Instagram. How you doing today?
Doing good, man. How are you?
Good. Welcome to the podcast.
Yeah, thanks for having me. I'm stoked to be here, man.
Yeah, glad to have you on. Today we're going to get into a ton of plant science that isn't really taught or talked about much. We have a decent sized list of things to get into, and I think this episode is going to bring a lot of value to those of you who are big into plant science. But before we get into some of the topics, we have a pretty decent sized list today that we can go through. Can you do an introduction? Maybe tell us a little bit about yourself and how you got into gardening?
Yeah, absolutely. So I am Blue, or BluegrassGreenthumb on Instagram and a couple other platforms. I am an indoor gardener. I am a farmer. I've grown several plants in many different scales, many different situations. I've managed large-scale nurseries. Kind of been hands-on with plants for, I think we said 6 or 7 years now, kind of on my own. Farming and gardening and plants have been in my life for as long as I can remember. My grandfather was a farmer. He's a cattle farmer. He did dairy and beef. He did tobacco, corn, kind of everything. He has hands in everything. And I got to be a part of that, sitting on the tobacco setter and helping plant, baling hay, the whole nine. I'm probably in the way more than I actually help. But it's kind of been part of me for a long time, so it kind of resonates with my soul, I guess. But yeah, that's really my background right now. I'm kind of shifting into more of an educational front, teaching natural farming techniques and teaching sustainability. Just kind of shifting mindsets from conventional ways into more sustainable ways, and I feel personally that it builds us as human beings as well, and we all know that the world might be able to use some of that good energy, right? So that's where we're at right now.
Absolutely. I know that just our short conversation that we've had through Instagram that you're really big into the sustainable side of things and the natural farming. And so that's what the suggestion for the topics were today. And I'm sure we'll get into a lot of things that relate to that. Awesome. So let's see, we have a long list of topics like I mentioned. Where do we start? Let's start with, talk to us about nutritive cycle theory.
Yeah, so mostly what I do, it comes from Korean natural farming is the methodology, the system. One of the big philosophies within Korean natural farming, or KNF, is the nutritive cycle theory. And this theory basically suggests that your plants require different things at different phases of the plant's life, right? So early in the seedling through vegetative stage, it can require more nitrogen. The crossover, a transition phase, requires something. So like in the Korean philosophy is like they compare it to a woman during pregnancy. She craves something sour. And so phosphoric acid. And one of the KNF inputs that we make is water-soluble calcium phosphate. So it feeds that sour craving, so to speak, in that transition phase. And then you have your ripening phase. So basically, it's the theory is the right nutrients in the right amount at the right time. So within the KNF system, we have all of these different inputs that are used at specific times at specific rates, and it all plays into that nutritive cycle theory.
You mentioned phosphoric acid, and I want to kind of circle back to that really quick because that's something that is, you mentioned you're using it in Korean natural farming, right? A lot of people use it as it's pH down is commonly phosphoric acid. And a lot of people are worried that phosphoric acid, if they're using those pH down products, they're killing off microbes. What's your take on that?
There's a lot of factors into play there, really. You don't, like in a living soil type situation, there's a lot going on in there with microbiology and humic acids, fulvic acids, and a lot of these things kind of create a buffer within your soil, and unless you're applying it in like extreme amounts, it's not going to really affect much. Now, speaking in terms of like a sterile grow medium that you're supplementing only like salt-based nutrients and stuff with, I honestly don't have enough experience or research into that to say for sure, but I feel comfortable that if I were to apply something like that into my soil, the biology there is going to take care of it and not going to cause issues.
Okay, that makes sense. Now, I know an area that you have a lot of experience on and that you really want to talk about is IMO. Can you talk to us about IMO, what that is, how you make it, so on and so forth?
Absolutely. Yeah, so within Korean natural farming, the big thing, the base of it all is IMO, or indigenous microorganisms. And you'll notice within KNF, like KNF, there's a lot of abbreviations, so I'm going to try to, reiterate these as we go. But yeah, IMO is indigenous microorganisms. When people first get into Korean natural farming, the first thing they want to go for is, well, how do I make my nutrients? Because it's just kind of the standard mindset. I need to figure out where I'm going to get my nitrogen or my potassium or calcium from, which, to a certain extent is important. But when you realize that the microbes have such a large factor in plants in general, in soil, and how it all works together, you realize that that's really more important than supplementing nutrients. Because you look at the tallest trees in the world, look at the healthiest ecosystems in the world. Who's fertilizing them? Who's going in and tilling those places? Who's spraying them with pesticides? Nobody. Because kind of nature takes care of itself. It adapts, it overcomes. It's evolution in a sense. The strong survive and they adapt, overcome, and make things happen, basically. So the thought behind IMO is you want to collect these microorganisms from these thriving areas. So you've got a really healthy, thriving forest that hasn't been adulterated by man. And you can find these patches of leaves that have stacked over years and years and years under that. And you can usually pull that away and find life in abundance, visible fungal strands and little critters and crawlies. So with IMO, we're collecting those guys because those are the strong guys, right? Those are the guys that are going to do our nutrient cycling, that are going to make our plants resistant to pests and disease and all that good stuff. So we're collecting those and we put them in a storage state, or as my mentor Chris Trump says, cryo freeze, kind of using a sci-fi term there. I've always liked that. You're mixing this collection on an undercooked rice, basically a simple food for the microbes to kind of grow up into. And after so many days, if you have a good collection, you mix that with brown sugar and it makes it shelf stable basically indefinitely if it's stored properly. And then from there, we're multiplying that out into larger substrates into different phases of the IMO process. There's IMO 1, which is the collection phase. IMO 2, which is that cryo freeze stage where you mix it with brown sugar. IMO 3, we're growing those out onto a substrate, usually a carbohydrate and a carbon source. Like I use rice bran, oats, crimped oats, rolled oats for a carbohydrate source, and then usually something like wood chips or leaves or sticks from the backyard as the carbon source for that process. That's IMO 3. IMO 4 is when you take that and you introduce that to your native soil. You're kind of creating this social gathering, so to speak, of the microbes you've collected from these different thriving ecosystems and marrying them with the microbes in your soil that you're growing in. Kind of getting everyone check and balance type situation. Everyone's situated, sorted out. So when you inoculate your soil with this IMO 4, everything's smooth and balanced. There's no shock. There's no, everyone's confused and the plant is kind of oh, I'm stressed out. There's chaos going on in the ground. But yeah, so you're essentially applying these big, strong microbes that have helped these forests and valleys and mountain life thrive for so long. And you're growing that out basically and applying it to your plants. So you're creating a similar ecosystem in your soil that your plants are growing in. And those microbes, for the most part, take care of everything else. And these other inputs are kind of just supplementing those microbes to do certain things.
So when you make that IMO solution, how long is it good for? Do you need to use it right away, or can it sit on the shelf for a period of time, or what?
So IMO, that's another cool thing. That's another really cool thing about it. Once you get to IMO 2, like if you just have that collection mixed with brown sugar, you can store that indefinitely in the right conditions. You don't want it to dry out. You don't, nothing like that. But you can take the serum, it turns into a liquid. That brown sugar kind of, through osmotic pressure, pulls all the liquid out and stores it. You can mix that liquid with water and just water it in that way. That's the most basic way to use it. Now, you can once you take it to IMO 3, it gets 100 times better. It's an arbitrary number, but it gets a lot better. IMO 3 also can be stored indefinitely. It's dry when it's done. It's just dry product that's inoculated basically. Same with IMO 4, indefinitely. You want to store it in something that is breathable, like a burlap bag or something like that. You don't want to store it outside in the rain and nature. There are certain conditions it needs to stay in, but you can use it that way. The IMO 3 and 4, you can top dress with it. You can mix it in your soil if you wanted to. You can also make what's called liquid IMO with any of these, IMO 2, IMO 3 or 4. And it's basically like a compost tea, but you are using some of the other natural farming inputs within this brew as well, and you're multiplying those microbes from your IMO into the water for 24 to 36 hours usually, and you can apply that to your soil and plants as well.
Okay, yeah, the liquid is what I was kind of mainly referring to, because I actually had another guest talking about IMO pretty recently, Green's Goddess. I think you might have actually watched that episode, but she had the liquid right there, and that's one thing I didn't ask her is how long is that good for? So it's good to know. Now, I am pretty new to IMO. I haven't created it myself. I know there's lots of listeners that are in the same boat as me. There are a lot of people that take notes during this, and a lot of people ask for sources in addition to it. Are there any books that you can recommend or websites or anything that, any additional sources that you can recommend that people can learn more about IMO?
Absolutely. So my mentor was Chris Trump, and Chris Trump was one of I think he was the first person, the first farmer in America to utilize these techniques on a large scale. And he actually had Master Cho, who came up with Korean natural farming back in the 60s. He actually came to Hawaii where Chris Trump was and kind of taught him the process and everything. But anyway, I've learned under him. I went to one of his like in-person classes. He has a lot of really great videos on YouTube explaining each part of the process, how to collect IMO, how to take it to the next steps, all the other Korean natural farming inputs. He's a really great teacher. If you have the opportunity to take one of his in-person classes, I highly recommend it. A lot of this is hands-on, and you can't really truly learn it until you experience it hands-on, done correctly, because of olfactory senses, right? You see something and you know if it's good or bad. Smell it. Our memory with smell is pretty incredible. You smell a good IMO pile one time, but you're like, okay, you smell it again, I know this is good. And also with bad, it's good to experience those things. So hands-on is great. Now, Chris Trump on YouTube, Eric Weiner or Drake on YouTube. He CGNF Hawaii. There's a lot of resources there to kind of dig into. But yeah, big thing is hands-on training. If you can get a certified instructor somewhere, highly recommend that. Some really great things to look into as well, not specific to KNF or Korean Natural Farming. The Teaming with series. It's a series of books. Teaming with Microbes, Teaming with Fungi, Teaming with Nutrients. Jeff Lowenfeld is the author, and he does a really incredible job of explaining a lot of this kind of scientific stuff in a way that most people can make sense of. And I find myself still revisiting those books frequently because it's like I learn constantly, and as I go back, something else like, oh, well, that makes sense. I didn't even think about it before. Highly recommend those things big time if you're just getting into all this.
That Teaming with Microbes is actually on audiobook now for anyone who is an audiobook person. I was listening to it on a recent plane ride that I had, and it's definitely more advanced. Like if you're a beginner just trying to get into it, sure, go ahead, try. But I think a lot of things will go over your head. But still, it's definitely a lot of great information. And you're right, it gets deep into the science on a lot of things. Talking about inputs, you said there's a lot of misconceptions about the different inputs that are used. There are so many different inputs that people put into their soil, right? What are these misconceptions that you're talking about on these different inputs?
Yeah, so specifically to the KNF realm, when people first get involved, again, they typically go for where are my nutrients coming from. So they like to go towards the like FPJs and FFJs. Everyone wants to make a banana ferment right off the bat, like, oh, there's my bloom booster, there's my potassium. And that's not exactly how it works. Please don't go to the store and buy plant material to ferment for your plants. It defeats the purpose, and I'll explain. But yeah, so like the FPJ and FFJ are more of hormone enzyme supplements. They are microbe food as well, and they kind of work in a sense that they can trigger the microbial. They can trigger the microbes in your soil to respond the way that they need to for the phase that plant is in. Again, going back to the nutritive cycle theory. So if you're making an FPJ out of the shoot tips of a fast-growing plant in the vegetative phase, you're kind of, quote-unquote, harnessing the energy from that plant, right? So when you apply that to your plant as a foliar and in your soil, those microbes are going to be like, oh, this is what I need to do in conjunction to, or in relationship with this plant to do what it needs to do. I'm going to bring this nitrogen to the plant or this, and that consortium of microbes is going to wake up basically and do what their role is in that plant's phase, because the microbes also change throughout the life of your plants too. You're going to have a different consortium of microbes in veg as opposed to late bloom. So these FPJs and FFJs, they kind of feed and wake up those microbes, so to speak, to do what they need to do for that plant's phase. So yeah, FPJ is not a nitrogen input. It's not a, It's not that. Your nitrogen, your vegetative type feed comes from FAA or fish amino acids. So when you're applying these nutrients, you should also be applying them with these other inputs. That's another big misconception is, well, I'm just gonna spray my plant with FPJ. Well, you don't want to do that because then you're applying just a bunch of sugar to the leaves of your plants basically, and well, you're really setting up a buffet for pests at that point. So if you're applying, let's say FAA in veg, you want to do a foliar spray. The nutrient input should also be applied with what is called maintenance solution by some, or SOS solution. So anyway, that is a combination of FPJ, fermented plant juice, BRV, or brown rice vinegar. Any organic vinegar will work. Just don't use white distilled vinegar. And OHN, or Oriental Herbal Nutrient. So all of these inputs in this maintenance solution actually work together in a sense. The vinegar, it acts as a cleanser. It can help with pests and diseases. But what's really cool about it is it can actually act as a catalyst for whatever you're spraying on your plants. The vinegar itself can, like the amino acids and stuff in it, can attach to these nutrients and compounds and make them smaller. Basically make the water molecule smaller so that it can enter the plant stomata easier, right? And get more out of it, basically. There's a lot of benefits to having all this together. OHN, it has warming or invigorating properties. It's anti-pathogenic. It's a prebiotic, basically. And again, the FPJ in there is kind of steering the microbes to do what they need to do. So if you're applying FAA for veg, you want to wake up those microbes for the vegetative phase, right? So that's very important. You don't want to apply any of these inputs by themselves. Maintenance solution is pretty much applied with every nutrient input within the KNF system.
You mentioned how some of these inputs can trigger hormones. I want to get deeper into hormones because that's something that we haven't really talked about much on this podcast in particular. Can you talk to us about hormones, what you know, why they're important, so on and so forth?
Yeah, that's a deep one. So, all plants have plant growth hormones, or they're kind of like natural PGRs, so to speak, but they're naturally produced. It's part of what the plant does. You have different things like auxin, gibberellins, cytokinin, abscisic acid, ethylene. And each one of these hormones plays a specific role within the plant. So, for example, auxin. Auxin is known for the elongation or shoot growth, basically, apical dominance of the plant. So, auxin, it kind of promotes apical growth in the plant, cell elongation. It's a technical term. So it kind of shoots up and it can help with root growth as well. So one majorly known auxin is indole acetic acid. That's the naturally produced one within the plant. So if you go look at a lot of the rooting hormone supplements, your gels and dips and stuff like that, you'll see indole 3 butyric acid. So basically all that is a synthesized version of this auxin that is naturally occurring in the plant, right? It's been isolated and you're basically applying this auxin to your plant to help promote rooting. So like with FPJ, that's a lot of what we're harnessing when we make those ferments. And I'm going to tie all this together now. When you make FPJ, one of the characteristics, or one of the things you need to be mindful of, is when you collect the material to make it out of, that it's done before sunrise, right? And a lot of people kind of ignore that, especially in the beginning, because they don't really see why. It's like, I just need the nutrients out of the plant's leaves or whatever. So plants have circadian rhythms, just like humans do. If you've ever noticed your plants when the lights come on or the sun comes out, they're usually, they pray up and they look happy. And then as you get closer to those lights turning off or the sun going down, they might start drooping down a little bit. Well, that's kind of the plant, in a sense, waking up and going to sleep with that circadian rhythm. Now with these hormones, things like auxin, in the morning time, as the sun's getting ready to come up, these plants are expecting these lights to come on or the sun to come up, right? Because of the circadian rhythm. So they take that energy and they shoot it to the plant's tips, get ready to photosynthesize for the day. They're going to take all this in and do their job. So the hormones are going to be in the highest concentration at the tips of these plants at that time in the morning. Because after the sun comes out and the plant starts photosynthesizing, the stomata close and all that good stuff. So you really want to harness that early on in the day, like as early as possible, before sunrise, as the sun is coming up. That's very important to get the most out of it, right? Because these hormones play such a huge role in the benefits of all this. The auxin, again, it'll cell elongation. It'll make the plant basically grow faster, and it has that energy that you harvested from that plant and you're applying it to yours. It's going to make it grow. And then you've got your gibberellins, your cytokinins. They all play a different role. Some cause branching, some cause cell division. So like actually producing plant, basically your leaves, your stems and flowers. So you're harnessing all of that from whatever you're making your FPJ or FFJ out of. So you also want to harvest your plant material based on the phase that that plant is in, right? You don't want to take a plant that is blooming or fruiting and make a ferment out of that and apply it in the vegetative phase, because that balance of hormones is going to be way off, right? With the way they all kind of work together, you change the ratios a little bit between these hormones and it'll cause your plant to do all kinds of crazy things. I've just with tests and trials, I've tried some of these inputs intentionally wrong just to see what kind of results would happen out of my own curiosity. And it's extremely powerful stuff, man. Like, I'm not gonna lie, these inputs are very, very powerful. So it is important to do it correctly in order to get the results that you desire. But yeah, you can get enhanced growth, better root development. There are enzymes within the FPJ that play all sorts of roles in breaking down nutrients and taking care of pest issues and powdery mildew, fungal diseases, all of that. So
That's super interesting. You mentioned PGRs. I think a common one that people talk about a lot is, and I have trouble pronouncing it, but Paclobutrazol.
Paclobutrazol.
I think I did an okay job. Yeah, right. Do you know anything about that? I mean, that's one of the ones that are highly frowned upon if people use it, because I believe it contributes to cancer, or has a link to cancer or something like that. Do you have any info on that?
Yeah, it's definitely a carcinogen. It's made for ornamental plants, not consumable plants. So right off the bat, that should tell you not to use it on something that you're going to ingest in any way, shape, or form. But yeah, it's a synthetic plant growth regulator, and basically, I believe what it does is it inhibits gibberellic acid production within the plant, so that, see, gibberellic acid is another cell elongation hormone. You know, it kind of makes things shoot out, grow tall, big. Your stem, basically, it promotes that growth. So when you block those hormones from being able to function, the plant stays squat, short. It doesn't grow as much. So it sends more of that energy through other hormones and sends those nutrients to the other parts of the plants, like floral development, and it can make them more compact, denser, heavier weight. But it really messes up a lot of other things too. You know, like, don't do it. There's so many other options out there. Like even within KNF, a lot of these inputs can kind of promote similar type results without putting your plant through that, without, you know, putting toxins into your plant, soil, and body.
Yeah, so one of the things you mentioned is the real compact, dense buds, and I think that's what it's mostly known for. Is people will receive this bud and it'll be super compact, and like, why can't I grow my plants to be this dense of buds, right? But it's unnatural and it's not healthy. So yeah, I'm glad you expanded on that a little bit and let us know exactly what's going on in the plant and you know why it's bad and so on and so forth.
Yeah.
Enzymes. Let's flip into that. What do you know about enzymes?
Quite a bit. Well, I won't say quite a bit. I surface level on a lot of it, but enough to kind of talk about it, I guess. Enzymes play a very important role in all of this, right? So microbes produce enzymes. You know, like I said, you've got this big consortium of all these different bacteria, fungi, yeast, and they all do a different thing. They may work in conjunction with each other or whatever, but they'll excrete these enzymes. And what these enzymes do basically is break down a certain thing and make it into a like plant available form, basically. So one of the big things right now is like soybean amino acids, right? Because it is an incredible input. All of that complete amino acid profile, it has all these precursors to different plant functions. So one of the ways that that is made is by taking enzymes and converting the high protein content within the soybeans into available amino acids. And some enzymes that are responsible for that process are things like papain, which is the milky latex substance that comes out of a skin of a unripe papaya. Like if you find a green papaya and you just like scrape your fingernail across the skin, you'll see this white oozy stuff come out. That's papain, and that is a protein digesting enzyme. If you look into like gut health supplements, digestive enzymes or probiotic, a lot of times you'll see papain in there, or bromelain. Bromelain is found in pineapples, another protein digester. So basically what they'll do is they'll take these soybeans and they'll add these protein digesting enzymes to break down the protein into amino acids, which are then readily available for the plant to uptake. And so with like fermentation and things going on within the soil, a lot of these similar types of enzymes are being produced to break down different things, whether it's proteins or carbohydrates and fats or whatever it may be. The more diverse and abundant your soil biology is, the more of these enzymes are being excreted. A lot of them are responsible for like pests. They can take care of pests too. So if you're spraying your whole plant, your grow area, and everything with like liquid IMO, and these microbes are kind of living everywhere on the surfaces of everything, you've got all that action going on. You've got photosynthetic bacteria on the leaf surface that are converting nitrogen from the air, making it available to your plant right on the leaf surface. All of these things. So enzymes play a very important role in making things available to our plants, basically from just organic matter. So that plays a huge role in everything.
That's incredible. So you're saying that there's some bacteria that can actually take nitrogen from the air, convert it, and then the plant intakes it through the stomata. Is that right?
Yes, photosynthetic bacteria. You can look into that. Nitrogen fixing bacteria. So things like legumes, soybeans or clover, they actually have these microbes that can convert nitrogen that is available in the soil or air into a form that is available for plants to uptake. And that comes from the bacteria.
Okay. I use clover right now as a cover crop, and I've heard it's good for nitrogen fixation. But from my understanding, the plant would create it and release it into the medium. Is that incorrect?
No, you're absolutely right. It's a symbiotic relationship, right? All of this kind of works in symbiosis. Like you can't have one without the other. It's like baking a cake and taking out one ingredient. What do you end up with? Usually not a cake. So yeah, it kind of works in that sense. The plant can photosynthesize and take nitrogen from the air, and it shoots exudates down and has a relationship with these microbes and an exchange that goes on and takes place. And then the mycorrhizal fungi are like, oh, there's free nitrogen over here. My plant says it needs nitrogen, so I'm going to pull it from over here back up for the plant in exchange for that plant's exudates or food for me or whatever I may need.
Do you feel, in your opinion, clover is beneficial in both large operations as well as small operations? Like I've used clover in small grow pots before, and somebody said, that's pointless. It's not really doing anything for your plant. It needs to be in a large pot, or you need to be outdoors and use clover and have that by your plants. What's your take on that?
Different situations are different, but there are benefits that you could still gain even if you're not getting the nitrogen fixation like we're talking about, such as having that mulch. You've got a living mulch basically, right? So another very important thing within all this is microbial development and fungi in particular. And when you have a cover crop that is an inch to 3 inches growing above your surface of your soil, you've got this micro environment basically in that area. And if you've got a top dress like amendments or a mulch or something there, you've got this perfect environment for these fungi and bacteria to come into and do what they need to do to break down this organic matter quicker for you and to thrive and populate, right? Whereas if you just have bare soil on top with the light sitting here baking down on it, those guys don't want to be there. You know, like you want that moisture to stay consistent. You want that environment to stay consistent. A general rule of thumb is 70% shade, 30% light. That's kind of like the perfect little environment or climate for them. So you're getting benefits like that for sure. And as it grows and you're chopping it down, you're reintroducing organic matter into your soil, which is nutrients, which is microfood, which is eventually going to turn into humus and organic acids that can act as chelators or make nutrients available to your plant, add carbon, all that good stuff. So yeah, it's definitely beneficial. I will say that you really want to make sure that you have your biology on point if you're going to utilize something like that. I have seen situations, I've had situations where things like clover and cover crops can actually be an attractant for pests. You know, it can actually bring things into the garden, because even if your plant that you're growing is healthy and thriving, if these clover down here aren't exactly thriving, then you've got a buffet, because pests go after weaker plants. They're easier to penetrate. They're easier to get nutrients out of. So just something to be mindful of. You know, keep an eye on it at the very least for damage. Like look at it as much as you look at whatever main plant that you're growing. Really, be observant in all of this. Observation is key.
I think another concern for people is that cover crops, it's often said that they're robbing nutrients from your main plant that you're trying to grow. Is that a concern at all for cover crops to rob nutrients, or use up nutrients that your main plant is going to need at some point?
Not really a major concern. Indoors, it might be a little bit different, but it shouldn't be to an extent that you're noticing observable effect or impact from it, especially if you're amending your soil properly, or supplying your plant with these different inputs that are nutritive inputs. I don't see it being that big of an issue. Now, I don't have experience like side-by-sides testing it or anything like that, or can't link you to any studies by any means, but just using the logic that I have, I don't think that is as big of an issue as people make it out to be.
Okay, good to know. Next up, we wanted to talk about hermaphrodites. I know you that's one thing on your list that you wanted to talk about. Talk to us about it. What do you know? What do you want to explain to everybody?
Yeah, and a lot of this is it's more known knowledge, but it still probably needs to be brought to the attention of more people. So everything that I do really revolves around how things happen in nature. Being nature observer, because nature knows what it's doing, and we're trying to observe and mimic that as much as possible. So I went down a rabbit hole years ago, like, why do hermaphrodites happen? And what it comes down to is survival. Just like every other plant response, basically, is some sort of means of a survival response or a stress response. So if a plant is growing in the wild, its major intention is to reproduce. Just like all other species, I need to grow up, be healthy, reproduce, so that my genes can carry on, basically. And in a situation that a plant isn't in ideal situations, and it has factors that stress it or make it think that its life is coming to an end, or it might not make it out on the other side, or it's not been pollinated, it can produce these different ratios of hormones within itself, basically, as a stress response, like a last minute resort, basically, to reproduce and carry on the next generation. So that, for one, is something that just think about, right? Like, hermaphrodites don't necessarily mean that the plant itself is inferior, right? So that's kind of the mindset that we have, is like, oh, those are weak genetics, like, well, maybe not. We could be looking at it all wrong, like, oh, this plant has the ability to do what it is intended to do in nature really well. It's all about perspective in that sense, I guess. We do grow for production and stuff like that, and that can hurt our final product. I just think that that mentality in general and that looking at it that way kind of I don't know. It changed some things for me, right? Like just looking at something as being inferior. I see a lot of people, you know, they get bashed over, you know, oh, I found a hermaphrodite in this pack of seeds. I know it's the only one out of 1,000 plants, but that breeder ain't doing his job, you know. Like, come on, man. This is nature we're dealing with, you know. Your plant's trying to survive, and you've got it in a situation it doesn't like. So taking that knowledge and thinking about the particular genetics that we're growing. If you've got a landrace variety of a plant from somewhere, let's say close to the equator, and you put it in a situation where its environment, its light schedule, temperatures, humidity, the microbiology is so drastically different from where it originates from, what do you think the plant's response is going to be? Stress, right? So things to factor, you know, what kind of climate is my indoor area? What kind of, you know, genetics do I need to be aiming for? Does in nature, did this particular combination of varieties would it prefer, you know, shorter days or hotter temperature or more or less humidity, drier soil? What kind of soil consistency? You know what I mean? There are certain things you can do to get close, but again, observation. Think through how does this happen in nature, and you can learn a lot from that that applies to more things than you realize, such as this.
I just finished a cultivation certificate at Utah State University. It's by Dr. Bruce Bugbee, Royal Hines, Mitch Westmoreland, a lot of guys that are deep into the science of things. And one section they had was on hermaphrodites. And what they're saying is there's no, how do I word this? It's kind of like inconclusive at the point. They feel it has to do with exactly what you said, genetic. There's a genetic factor into it, and there's a stress factor into it. Those are the two main things, but they're still continuing to study that. Now, you mentioned through Instagram that some KNF supplements could potentially prevent it. Can you expand on that?
Yeah, so this is definitely not hard data, and I don't want anyone to take this as such. This is some trials that I plan to run in the future, and I want a few more people to get involved so we can have some more data. But going back to using these inputs as hormone supplements, right? So if you've got a plant in the transition phase and the reproductive ripening phase, you're using these fermented plant inputs for that phase. And I have a theory that if you had a particular plant that was prone to throwing pollen sacs or bananas or whatever you want to call it, if you can supplement that plant with the right ratios of hormones that the plant needs in that phase to do what it needs to do, that it might prevent it from shifting its own hormones into, oh, I need to, you know, change my stuff up to pollinate myself to carry on my generation. Kind of acting as like a precursor, so to speak, to doing what the plant you want the plant to do. Crop steering, in a sense. Now, I know these are bold statements and bold words. I'm probably going to get blown up for this one, but it is something that interests me, and I think there might be something to it. So I want to play with that and see what we can come up with there, because that might be a natural alternative or solution to some of these headaches that we're dealing with, and it might make it more enticing for people to really dig into the realm of natural farming too. So if we can get that win, then that's a win for everybody.
That is really interesting, and I'm definitely glad that you're digging down there. It's something that clearly interests you, and you're taking action to try to experiment and figure things out there. So that's cool to hear. Epigenetics. This is kind of a hot topic. I mean, there's some people that don't believe in epigenetic drift, for example. Can you talk to us what you know about epigenetics?
Yeah, not super scientific about it, but there are certain factors that I've noticed firsthand. In particular with seeds, I've noticed that, well, and you know, cuttings, clones as well. If you've got a variety that has been, especially for multiple generations, developed in a living soil situation with a robust microbiology, it's all proper nutrients and all that stuff in the right conditions, it's healthy, it's thriving. The thought is that the next generation, the seed, is going to carry a lot of that information so that it's ready to respond to a similar situation, right? It's kind of thinking back to taking a landrace equatorial strain and growing it in Canada. You know, that seed, it knows like what to expect. You know, that's within its DNA. Well, I think that a lot of this tech kind of plays into that too. If you've got a variety or a clone that is used to growing and being produced in a sterile situation, and then you throw it into a bed that's had IMO4 inoculated into it for the last 10 years, it might freak out. It might not do good at all, and vice versa. You know, all of my strains that I've developed have been developed in living soil, and you know, if you throw those into a sterile salt-based type situation, I can't guarantee they're going to do real great, you know. But I have seen that. I've gotten seeds from many different breeders, and I do everything pretty much the same way. I've experimented with salts and different things just out of curiosity. But I have noticed that the breeders I get from that practice similar methods as myself tend to do a lot better right from the get-go. You notice it even from the seeds sprouting out of the soil. It's pretty wild. They just tend to be more vigorous and robust and happy, healthy. They don't have as much damping off or stress issues, and they just generally thrive. And there was actually, I did a pheno hunt of 50 seeds, and there were like 5 seeds all from different breeders. And there was one that was a strictly salt-based grower breeder, and that was the only strain that none of them made it. You know, and there could have been several factors involved there for sure, but I just thought that was interesting too. And that's really like what interests me and what I think about as far as epigenetics is concerned. I won't get into genetic drift and all that stuff. That one's, I don't need to be blown up for my thoughts on that one, but yeah.
All right, fair enough. Awesome. So we are getting towards the end of the podcast here. Thank you so much for coming on, Blue. This has been awesome. Definitely dropped some good knowledge bombs of some science that isn't really talked about much or taught about much, like you had mentioned to me through Instagram. So wrapping things up, tell us, how can the listeners find you, and what do you have upcoming in the future?
I'm on Instagram as BluegrassGreenthumb. This is actually probably the first time that 98% of the people that follow me on there will actually see me or hear my voice. So, hey y'all, this is Blue, it's your boy. So yeah, find me there. We've got a Patreon rolling officially finally now. I have a Discord set up. I'm doing some exclusive content, tutorials, breakdowns, stuff like that going on. We've got a really great community there. Come hang out with us. Yeah, that's really my main things right now. Again, I've been kind of behind the scenes for many years now, so we're getting things rolling in towards this educational direction. So look forward to hearing from you guys.
So is this a face reveal?
Yeah, it is.
Admin reveal. There we go.
Yeah.
It's an honor. It's an honor to have your face revealed on the podcast.
It's an honor to be here, man. This is all very important stuff to me. Something I'm very passionate about spreading and getting other people involved in. So having this kind of platform and opportunity to talk about it and spread some information is really huge to me. So thank you so much.
Thanks for coming on and sharing. And for those watching on YouTube, I'll definitely have a link to his Instagram down in the description section below. And if you're on one of the podcast platforms, just search for him. You'll find him on Instagram pretty easily there. So if you enjoyed this episode, click that thumbs up button. Also subscribe to the channel if you haven't already. Every single weekend, I am releasing a new Garden Talk podcast episodes, and I would love for you to tune into future episodes. Blue, once again, thank you so much. Hope you enjoy the rest of your day.
You as well, man. Thank you so much.
Peace out, everyone.